before I get started on the lesson, don't forget, yesterday I gave you a day to work on stuff. The daily videos are due tonight. That means completed, not in progress or anything like that. So when I'm done with notes, if someone wants me to look for them to make sure that you got them done, I can do that. And the progress check is due Friday. So please don't forget about these things. They're easy homework points, guys. And sometimes you're on the cusp of a certain letter grade, from an A to a B, a B to an A, or a C to a B. These points can make the difference, okay? You have a lot of control over these points. You may not do great on every quiz or test, but homework points you have a lot of control over. No, they're homework, 4 points each. Yep. Okay, any other questions about that? No? Okay, so we're starting our trig unit today, unit 3, and we'll be using trig pretty much throughout it. We also do polar equations in this unit, which is another brand new thing for everyone. Some of you have done a little bit of trig, very little, but all of you will have polar that's new. If you had me before or Miss Shackton or have ever been in this hallway before, you might have noticed those those projects I have hanging in the hallway and we vote on them. That's polar. That's coming up this unit. Those pictures I have hanging up there, and you've seen them in the hallway maybe. So that's this unit 2, kind of a fun thing. Don't be stressed if you're not artistic. We'll talk about that later. But this is our last unit, and I have to tell you guys, everything I've been teaching you all year kind of touches mostly, like semi-log plots is really new, but like you had to do some stuff with graphs and calculators, lots of factoring, stuff you've seen before, so you could kind of half listen. For a lot of us, this is going to be brand new, and it's so important. I cannot stress to you enough how important it is for you guys to learn the stuff in the very beginning of this unit to be able to be successful in the whole unit, okay? So if you're someone that half listens to me, is absent a lot, or whatever, you're going to have to watch videos. You really, really, really will, okay? So don't miss any of my lessons, whether it means you're absent, you watch a video, or you're here and you're present. Make sure you are. Because what we are heading towards, the whole key to trig is this, okay? This is called the unit circle. We start working on this, I think, on Friday. And by a week from Friday, you'll be timed on it to have to finish it within a timed amount of time. Now, I said that to scare you for a minute, but I want to tell you something. I'm going to brag for a minute, okay? This part is not bragging. I'm horrible at remembering things. I can't memorize anything. When my social studies teachers made us memorize the presidents and the capitals and I couldn't. My brain doesn't memorize. I am going to go into the thesaurus, find a new word for memorize because I hate that word. You have to memorize this, but the way I teach it to you, this is the bragging part, I feel like I teach the unit circle very, very well. Because I'm not a memorizer, I have so many tricks and tips for you that actually there's going to come a moment for my students that try, which is going to be you all, that it just clicks. You're like, oh, and it just falls into place like a puzzle, kind of. And then you just know it. Once you know it, like you know your name, like you know the multiplication facts, things like that, okay? Please don't be intimidated. This is very, very patterned, makes a ton of sense. I have so many good tips and tricks for you. We're going to make it fun. I have a song, all kinds of things. But to understand the unit circle, which is the basis for tons of stuff after, we have to start here. And so just pay attention. So today, tomorrow, Friday, new material. Monday will be a work day. So if you don't get your homework done in class because you had to go a little slower, you needed some help or whatever, you're fine. Don't stress. Monday, there's no homework check, and it's a day just to get caught up on these 3 days, okay? So just relax and pay attention. Ask questions if you need to. Take good notes. The end of the speech, okay? All right. So if you watch the videos, you kind of got a rundown of what it says in this first paragraph. A periodic function is any function that repeats its values on regular intervals or periods, like your breathing, your heartbeat, waves in the ocean. They have that same pattern over and over again. This phenomena repeat the same activity at a steady pattern. The most famous periodic functions are the trigonometric. That's a mouthful. Trigonometric. That's where trigonometry comes from. Those are sine, cosine, and tangent. And we're not talking about sine, cosine, and tangent today. I don't think we do until Friday. But this is going to give us an introduction to what we're heading into. Also, light waves, sound waves, phases of the moon. So there's a lot of periodic phenomena in science, okay, and just natural occurrences on Earth. Okay, so it's really kind of a cool topic. Let's go through some vocabulary that we have to be really familiar with. These are going to be things we talk about in almost every type of graph we do. So we just talked about what a periodic function is. It's any function that repeats a pattern of y values at regular intervals. And here's a graph of a periodic function. And you can see a lot of times they look like waves, okay? We're going to get into some weird ones that have like pointy stuff going on in it here. But when we get to sine, cosine, and tangent, they're very smooth and curvy and predictable, and you'll see that when we get to it. Let's talk about cycle and period. Cycle is one complete pattern of the y values, and really the x values, and a period is the horizontal length of one cycle. Okay, so let's talk about that like with this graph. Was that the graph? Really, really important stuff when I put them on your desk. Okay. So let's talk about this graph. As you can see, it's just repeating. Pick a point to start with on your graph. It doesn't matter. Okay. So if I say, for example, I'm going to start at this point. I want to travel along this graph until I get back to my starting point. So if I start here and I travel, I would get to about here. That's a cycle. That's one period. The words are kind of interchangeable. Don't get stressed about that. So from 0 to 6, that is one cycle. Okay? So we could call, I'm going to write it right here. We could call one cycle of this graph from 0 to 6, approximately. I know it's not exact. Don't worry about it being perfect right now. When we get to the trigonometric ones, they will be exact. There's not going to be a lot of decimals or anything, so just round it to whatever you think. It's approximately 6, from 0 to 6. Okay? So what is the period? That is a positive number. It's the distance from the starting point to the end point. How much of the x-axis do we use to make that cycle? 6 units. From 0 to 6 is 6. You could count. 1, 2, 3, 4, 5, 6. Okay? But there's an endless number of cycles on here. Remember I said pick a point to start at? I could have started here. If I started right here and I traveled along the graph till I got back to where I completed one full cycle, you can see here to here, that is one full cycle. That cycle would be from, what is that, -3 to, that's not right. Is that -3 to, yeah, it is, sorry, to 3. I was thinking that was a distance of 10. Dumb, sorry, -3 to 3 is not 10. But, so that's the name of that cycle, like from there to there. And it's a different shape than the one I did in pink, but it doesn't matter. It completes one full pattern. It starts, there's no starting or ending point on these graphs. They just go on forever and ever in both directions. What will stay the same is the period, because from -3 to 3, that's still just 6 units of the x-axis, right? 1, 2, 3, 4, 5, 6. And so I could name as many cycles as I could the rest of my life on this graph and never get to the end. It's an infinite number, depending on where you start, where you end, and it goes on forever in that direction, that direction. What they all have in common, though, is the length of the cycle. The length of the cycle is always going to be 6, okay? Now we're going to talk about something called amplitude and midline. These two go together, right? And midline was not put on here. We're going to add it on here because midline makes life easier. Midline is exactly what it sounds like. It's a line in the middle of your graph. It is the horizontal line where half of the function is above the line and half is below. Midline. And I'm going to give you a formula for that once you finish writing what it is. But once we know the midline, the amplitude is really, really easy to find. And amplitude and midline later on are going to be 2 of the 4 numbers you plug into a formula. So knowing them now is going to make your life so much easier later. And trust me, it's simple, okay? So midline formula. So if you want to find the middle of something, you guys already know this. You already know the formula. If you want to find the middle of 2 numbers, you add the 2 numbers together, divide by 2. Like if I wanted to find the average between Evan and Jaden's last quiz grade, I would add them together, divide by 2. The average is the number in the middle, right? How about midpoint on a graph? And you have to find the midpoint. You add your x values together, divide by 2, add your y values together, finds the middle. That's mid. So the formula is really simple. You take your max plus your min and divide by 2. So looking at my graph, my max value is 1, right? That's as high as it goes. My min value is -1, right? That's my max 1, min -1. If I add 1 plus -1 together and divide by 2, I would get 0, right? So the midline of this graph would be 1 plus -1 divided by 2, which gives you 0. So this graph has a midline of 0. And you didn't even need a formula for that on a graph like this. Anytime your min and your max are the same number, just different signs, 0's in the middle, right? 5, -5, 0's in the middle. 100 and -100, midline's in 0, a 0. But it's not always going to be 1 and -1 or 5 and -5. And that's why the formula is really helpful, okay? Now, let's get to amplitude. The amplitude, and I don't like that definition, the amplitude is just how high and how low we go above the midline. So the amplitude, look, so you don't miss it, is this distance right here. From here to here, that is your amplitude. Or you could do it from here to here. It's the same distance, okay? So from here to here, from 0 to 1, what is the amplitude of this graph? 1. So again, if 0's in the middle, your amplitude is whatever your max or min value is. And amplitude is always positive. It's a distance. Period is always positive because it's distance. So these 2 guys are always positive. You can't go a negative distance, typically. I know some of our science people will say, well, like below sea level and stuff like that. Don't overthink. Amplitude and period for us is always going to be a positive number. How much of the x-axis do we use? That's period. How high and low above the amplitude? That's on the y-axis. But it's distant, so it's positive, okay? Now, I'm going to give you the formula for it, but I never use it, all right? I offer you things that you can use to find things. Some of you, like one more than, I can't think of the word I was going to say. Some of you will like one way of doing something than another. I'm just giving you different ways. It's never work you have to show or anything. You just have to be able to look at a graph and find the amplitude. Again, I'm going to be modeling it this way, find the midline and then find the amplitude. We'll practice that in a second. But there is a formula for the amplitude, but I almost want you to forget about it. But here it is. You subtract the 2 of them, find the absolute value, because it's always positive, and divide by 2. Okay? So in that case, it would have been, 1 minus -1, which would have been 2, divided by 2 is 1. So that would have been that. But it's so much easier to do it with midline, and you need midline anyway. So here, let me show you what I mean. For example 1, A and B, we have to identify one cycle 2 different ways and find the period. Okay? I'm going to add in 2 things. I'm going to add in midline and amplitude. And from here on out, you'll probably never see me write those words out. I just write mid, amp, okay? Write whatever you want. So in any order, let's kind of get organized. We're going to eventually find all of these things. However, whatever order, like I said, doesn't matter. So let's do this for 2 graphs. So take a second, look at your graph. So first thing is the period. That's how much of the x-axis do we use to complete one cycle. So pick a starting point. Everyone can pick their own starting point. You don't have to match it with me. I try to use 0, like the y-axis, so x is 0. That way it makes it easy to count how far out I go. So in this case, I would go up to my max, down to my min, back to the middle. Okay? That is one cycle. That cycle's period is how long. So from 0 to 4 is 4. That's how much of the x-axis, 4 units. The one I just did would be from 0 to 4. That's interval notation, from 0 to 4. But let's name it another way, because you might have picked a different starting point. It doesn't matter where you start as long as you make one complete cycle. So here I started in the middle. Why don't I start at a max? So if I start at the max, I have to go down to my minimum, back to where I started. Okay? So that's another cycle, which is -3, 2, 1. But it's still a period that's distance of 4, right? 1, 2, 3, 4. That is 4 units of the x-axis, okay? There's only one period. Cycles could be named however you want, really. All right, let's find the midline. Well, to do the midline, we need to know our max and our min. So here's my max at 2. Here's my min at -2. That makes my midline super easy. I don't really need to use the formula. I know that the midline is right in the middle of 2 and -2, which is 0. But if you did do the math, it's 2 plus -2 divided by 2. You get 0 over 2, which is just 0. And again, I don't ever need to see the work for a formula like that. Amplitude is our last part. What is the distance between, and you can start anywhere you want and go up to the max or go down to the min. So from here to here, that is my amplitude. What is that length? 2, right? 2 above, 2 below. Doesn't matter. So counted here, here, and it's always positive. Right? Let's do another one. Period, mid, amp, cycle. So when you're finding your period, when you're like picking your starting point and traveling through, you have to get to your min and your max, right? So like, how do you decide? Like, why isn't from here to here the only part? Well, I haven't gone the whole way. I haven't hit every possible point from top to bottom. And you always want to end where you started. So if I make this my starting point, remember you pick your own starting point, I would have to go all the way down as far as I can go and then get back to where I started. That is one period. That cycle's name would be from 0 to what? From 0 to what? 3, right? That's the x-axis, from 0 to 3. That's one cycle. How long is that from 0 to 3? That's 3 units of the x-axis. Let's find another cycle. And this part of your answer can be different from everybody in the room. Same, there's no limit to how many. So if I like pick this as my starting point, I have to travel all the way the length, have to hit my max, and end up where I started. So that cycle, if I use that one, would be from -1 to 2, which, guys, is still 3 units of the x-axis. 1, 2, 3, right? That uses 3 units of the x-axis. The period is the period is the period. Okay? So looking at my mid, I have a max of 1. I have a min of -2. Divide by 2, I get -1/2. Right? Max plus min, divide by 2. It can be positive, it can be negative. This one happens to be negative. So having my midline to my max from negative 1/2 to 1 or 1 to negative 1/2? How much of a distance is that? From here to here, what's that distance? 1.5, 1.5, 3/2. Write it any of those ways you want. Any of them is fine. Okay, you're doing great. Next page. Here in example 2, and these are going to match up just like your homework problems just like this, okay? In example 2, determine whether it's periodic or not, and if it is, what's the period? So periodic, we think patterns like, the waves, the same thing over and over, and this is a pattern, right? You guys could predict if I extended this graph, Jaden, if I extended this graph in both directions, you guys could probably keep going with it and be successful, but that doesn't make it periodic because you don't have a set max and a set min, right? Like, where is the max? Is it here or is it here? This is not going to repeat all those times. So even though this is predictable, this is not periodic, okay? But this one is, it just keeps going to the same height, high, the same low, the same high, the same low, the same high, the same low. So this one is periodic, yep. So since it is, we can name the period. How much of the x-axis do you use? And so pick a starting point. I like to start where x is 0, travel along the whole length and end up where I started. So that's approximately 0 to 4. But really, you could have started anywhere, but you can see why starting at 0 makes it simple. Because you're going from 0 to 4, that's 4 units. Okay? Anytime, this is my advice, anytime you're asked to find the amplitude, find midline as well. It seems like I'm giving you extra work, and I guess I kind of am, but it makes sense. It makes finding amplitude easier, and it's going to be a step that you have to do anyway later on, so let's just get in the habit of it. So finding midline is that really simple formula. Max plus min divided by 2. And again, negative 1/2. And labeling it on your graph is something you'll have to do later. And it makes it so much easier just to look. So if my max is 1 and my midline's at negative 1/2, just like the problem we just did, that distance is 1.5, right? So 3/2, however you want to write it, those different ways. Okay? Guys, you're doing great. Stay with me, stay awake, stay with me, stay with me. Daniel, you need to be awake. All right, so guys, here we go with mid and amp. So our max is 4. Our min, careful, I missed this. This is counting by 2s, right? So this is negative 2. So 2, 4, this is negative 2. So max plus min divided by 2, that's 2 over 2, or 1. So that would be right in the middle of 0 and 2. And then from 4 to 1 is 3. I'm going to skip example 4. There is one in your homework just like that, just like this, and you'll do it in class. You'll see it up there. I wrote you a note. Sound waves look like these. Doesn't matter really where you start, where you end. It'll make sense when you see it. It's just like this. If you need help with it, of course, I'm here, but I think we'll be able to catch on by the example, the key. Okay, so I'm going to go on from that. All right. Example 5 that I really wanted to get to. We are going to be getting into, eventually, some pretty challenging word problems with our periodic phenomena. In fact, FRQ 3 is one that we're going to work a lot on when we get to the review part of this class. FRQ 3 is a word problem with trig, okay? And I have so many examples for us to do. I have really great ways for you to understand them. But here's our first introduction to what one looks like. Consider how the pedals on a bicycle rotate as the bike is being ridden. Okay, so tons and tons of questions that have to do with something that's circle and that moves, okay? And you're going to see over and over again, motorcycle wheels, bike wheels, Ferris wheels, okay, clocks, anything that moves in a circle is really great examples of periodic phenomena. And so I'm going to show you what I mean. The height of a bicycle pedal varies periodically as a function of time. The max height is 18, the min is 6. So think about it. You have a bike wheel that is 18 inches from the ground at its highest point. So we call that 18. At its lowest point, it is 6 inches from the ground. Just picture a tire, a wheel of a bike, okay? And you start with your foot at the top, and you travel around, and you end up back at the top. So going around a circle one time is like one period, okay? So if you look, they gave us a table, and they started it for us, and our first task is to finish it. Time is almost always your x-axis, okay, and height a lot of times is your y, or y is usually height or something else. But x-axis, if you're talking about time, that's your x-axis. So look, so we start at the top at 0 seconds, right? Your foot is here. And then as time is going by, they're marking different heights. So we're at 15 inches, we're at 12, we're at 9, and then we get to 6. So after 1 minute, 1 second, we end up, our foot is at the bottom of the pedal. And then we travel back up. We're at 9. Then what would we be? How long, what would this one be? 12, right? They're the same height from the ground. And then it would be 15. And then back after 2 seconds, we're back where we started. So the period is, how much of the x-axis does it take? How much of the x-axis does it take to make one cycle? What do you say? What say you? Which is how much? How long did it take for us to start here and end back up? 2 seconds, right? If I graph this, which I'm going to graph a little bit of it in a second, one cycle would take us 2 seconds. I'll go ahead and label it, right? The amplitude, well, this girl doesn't like to find amplitude without midline. Midline is super easy. They gave us our max is 18, it said that, and our min is 6. So 18 plus 6 is 24. 24 divided by 2 is 12. Life is so much easier with a midline because I know how high I'm going to go above that. I'm going to go up to 18, and how low I'm going to go, which is 6. What is the distance between 12 and 18? 6. And we're talking about inches, so we'll just keep it like that, right? And now it says to graph for the first 5 seconds. That's going to take too long. Let's just graph a few points. At this point, these are just ordered pairs. Take a look at your x-axis. It's counting by 0.25, 0.5, 0.75, 1. So we start at 0, 18. 0.25 is at 15. Then we're on our midline, right? At 0.5 seconds, we're at 12. At 0.75 seconds, we are at 9. And then we get to our minimum at 1 second, we're at 6. And then it just travels back up again. And I'm not going to graph the whole thing, but you could see that this would just keep going and keep going. It would look like that. Okay. You can see I didn't graph it last year. I cut it out and put it over there to put on Canvas, so I will put the whole thing on Canvas, but we don't need to waste time. It's just going to repeat, right? You just keep going around in a circle and around in a circle. This is what it would look like on an XY axis, right? It makes a wave, right? So that's that. Last thing, A and B, this is just doing some conversions. Think about what this is saying. I'm almost done. A periodic function goes through 5 complete cycles in 4 minutes. So it does its pattern 5 times, and it takes 4 minutes to do it. What is the period of the function in seconds? Well, they gave us minutes. We need to change it to seconds. So we have to do a little conversion. 4 minutes would be 4 times 60, right? 60 seconds in each of those minutes. So 240 seconds. So now, what is the period if in 240 seconds we're able to get through 5 of them? You just divide. So, yep, and I just put that in my calculator. What is it? 48, yeah. So it takes 48 seconds to do one cycle. So you did 5 cycles, which is a total of 240. One of them was 48 seconds. Okay? They give us the period is 8 seconds. How many cycles do we go through in 30 seconds? So we spend 30 seconds doing this pattern. Each of them is 8 seconds long. So how many cycles did we get through? Again, just division. So the total number divided by one of them gives us, 3 and 3/4 is 3.5. Okay? We're just doing a little conversion there. And that's it, my loves. So finish writing that, go over to page 7. It is so hot. Does anybody think it's crazy? Has anybody given some thought to the calendar? About 3 months ago, mid-October, it was hurricane, tropical craziness, right? In Florida, of course, north of us with all the flooding and stuff. And now it's snowing there. It's snowing on the beach in Pensacola and Jacksonville. Have you guys seen this? Snow on our beaches. It's so crazy. They're like closing school. Snow days. Never had a snow day. That's crazy. Sorry. Here's the assignment. On 6 through 9, you'll see on my key, I added midline. Because if it asks for the amplitude, I want the midline too, so I added that. But you'll see it when you get to that. So I did that. But I just think it's crazy. It was just 3 months ago, guys. Hurricanes are tropical weather, right? Tropical. And now we're having Arctic. Just 3 months later. It's crazy. And it feels like the desert in my classroom for some reason. It's so hot in here. Take it. No, it's not the end of the world. No. All right, do we have that written down? Okay. Okay. If you need help, ask a neighbor, ask me.